What's good, YouTube? My name is Nobody and welcome to the Large Grid Ship Mega Guide. In this guide I'll be teaching you everything I know about large grid ships. If you gain anything at all from this video, please be sure to hit that like button and think about subscribing with the bell notifications to receive an alert whenever I release another video. Strap in because this guide moves quickly. To build a minimal atmospheric thruster powered ship, you will need to place thrusters with their thrust vectors placed in every direction except up, as gravity will pull down on the ship. If you plan to use autopilot on this ship, you will need one placed pointing up. You will need a power source such as a battery, hydrogen engine, solar cell, nuclear reactor, or even a wind turbine. You will also need at least one gyroscope and a control surface such as a cockpit, seat and remote control combo, or a remote and antenna combo. To fly the ship, simply hop in the seat using the F key on the keyboard or X button on the Xbox controller. W will move forward, S will move backwards, A will move left, and D will move right. You can adjust your roll with the Q and E keys. Space will move up and C will move down. Moving the mouse will change the direction you are facing. On the Xbox controller, the left stick will control your forwards, backwards, left, and right, while the right stick controls where you are facing. To roll, hold down the left bumper and use the right stick. You can build a cheaper version by replacing the control seat with the passenger seat and remote control. To control the ship, simply hop in the seat and hit the K button. Navigate to the remote and choose control. On the Xbox, use the right menu button instead of the K key. To exit, hit F twice on the keyboard or X twice on the Xbox. You can turn your ship into a remote control drone using a remote and antenna. Remember, always pay attention to the direction the remote is facing. It should look like the icon with the button on the front and the slot pointing up. To control the drone ship, simply hit Shift K on the keyboard or use the right menu button on the Xbox controller and navigate to remote access. Then choose your ship and hit control. You will then lose control of your character and will have full control of the drone. To exit this, simply hit F on the keyboard or X on the Xbox. The different options for recharging a large grid ship are hydrogen engines, solar panels, wind turbines, and nuclear reactors. You can also connect to a base using a rotor or connector. Hydrogen engines supply 5 megawatts of power at max output and require a hydrogen source to function. Solar panels output around 131 kilowatts of power at max and require sunlight to function. They will have less output if they are not facing the light source. Wind turbines require a connection to the ground through a landing gear to function. They output around 351 kilowatts at max with optimal wind clearance. Small nuclear reactors require uranium ingots as fuel. They are capable of outputting 15 megawatts of power. Large nuclear reactors are capable of outputting a staggering 300 megawatts of power, making them the most powerful power source in the game. A few options for atmospheric ships are large mining ships, cargo ships, welding or grinding ships, and even mobile bases. You can also make them into hybrids. To make a hydrogen-powered ship capable of planetary and space travel, you will need a hydrogen tank, and it's recommended to also have an O2H2 generator on board to refuel in case you run out of fuel. You will still need a battery as well to power the electrical blocks such as the cockpit and gyroscopes. You will also need a control block, such as any discussed earlier. You will need thrusters pointing in each direction, including up for space travel. Each thruster will need to be connected to a conveyor port, and a conveyor block makes it easier to get good coverage, as you can fit 5 small thrusters on each in different directions. To make the ship easier to fly as efficiently as possible, place a large thruster pointing down as well. You will also need a gyroscope. Once your hydrogen-powered ship is built, fueled, and powered, you can hop in and set the large thruster for maximum efficiency. To do this, press G on your keyboard and find the large thruster in the list. Drag this down to an empty slot on your bar and choose Thrust Override Increase. Repeat this for Thrust Override Decrease as well. To do this on Xbox, simply hold down an unassigned D-pad key until the menu shows. Now that you are set up for efficiency, be certain that you are level with the horizon using the ball to the right of your action bar. Once level, use the key assigned to your thrust override increase until you begin to accelerate upwards. As soon as you begin going faster than 90 meters per second, hit the key assigned to reduce thrust override and let yourself slow down. Once below 80 meters per second, increase it again. Keep alternating between 80 to 90 meters per second all the way to space. As your altitude increases, your planetary gravity or P-gravity indicator will reduce. As this happens, you will need less and less thrust override. This will continue until you will be toggling it off to slow down. Before that happens, be sure to cut off your inertial dampeners by hitting the Z key on your keyboard or the left bumper and the Y key on the Xbox. This will prevent your ship from wasting fuel by trying to stop itself. Once your P-gravity indicator drops below 0.05, you will be free of the planet's gravity well, and you're free to turn off your thrust override and turn on your inertial dampeners. If done correctly, you can get to space with very little fuel. In this case, I only used 3% of my hydrogen tank to reach orbit. As with any space build, to build a minimal ion thruster ship, place an ion thruster facing in every direction, including the up direction. You will also need a power source, control block, and a gyroscope. The jump drive is unique to large grid ships. It will allow faster than light travel. A single jump drive requires 32 megawatts of power to charge at its maximum speed and will not work until fully charged. With maximum charging, it takes 7 minutes to recharge. For the easiest access to jump drives, add the options jump, increase, and decrease distance to your hotbar. When a jump drive is ready to jump, the lights will turn green. You cannot jump without full charge. The amount of weight the drive is jumping affects its max distance, and you can add extra jump drives to rectify this. A blind jump will jump forward at the set distance in the direction you are facing. For safety reasons, you cannot jump into a natural gravity well. Also, any speed you have before jumping will be carried through the jump, so be careful jumping near a base or any other ships. Once you have visited a planet, you can create a GPS marker outside of its gravity well to return at any time you wish. To return to a GPS signal, simply open the control panel for any of your jump drives and select the signal on your list at the bottom. At this point, the jump command will jump to the GPS coordinate, regardless of your speed or direction. And finally, the jump drive will carry any ship connected to your ship through a connector, landing gear, rotor, or piston. Due to the large radius of the large grid ore detector, one common use for a large grid ship is a detector or exploration ship. Another common use is in a large drilling ship. These can be very large. They are useful for drilling and tunneling as well. The cargo ship is a normal choice for a large grid ship, as is a mobile base. If you can do it in a base, it can be done on a large grid ship. The efficiency numbers for the large grid thrusters are as follows. There are a total of 6 thruster types you can use for a large grid ship. These include small and large atmospheric thrusters, small and large hydrogen thrusters, and small and large ion thrusters. Small atmospheric thrusters are 1 block by 1 block by 3 blocks in size, as opposed to the large atmospheric thruster, which is 3 by 3 by 5. It takes 9 small atmospheric thrusters to fill the space of a single large thruster. These thrusters are electrically powered. Atmospheric thrusters only work in atmosphere. Small atmospheric thrusters are capable of 572.4 kilonewtons of thrust for a cost of 2.4 megawatts at an efficiency of 4.19 watts per newton. They weigh 4,000 kilograms. Large atmospheric thrusters are capable of 5.7 meganewtons of thrust for a cost of 16.8 megawatts at an efficiency of 2.95 watts per newton. They weigh 33,970 kilograms. Smaller is better in the efficiency calculation, so large atmospheric thrusters are more power efficient. Small hydrogen thrusters are 1 by 1 by 1 blocks and require a connection to a hydrogen source such as a hydrogen tank or O2H2 generator. A large hydrogen thruster is a 3 by 3 by 3 block and also requires a hydrogen fuel source. Hydrogen thrusters are efficient both inside and outside of the atmosphere. Small hydrogen thrusters are capable of 1.1 meganewtons of thrust in and out of atmosphere for a cost of 1.2 cubic meters per second of hydrogen at an efficiency of 1.1 times 10 to the negative 6 cubic meters per newton. Large hydrogen thrusters are capable of 7.2 meganewtons of thrust in and out of the atmosphere for a cost of 7.5 cubic meters per second at an efficiency of 1.04 times 10 to the negative 6 cubic meters per newton and weigh 6,940 kilograms. Large hydrogen engines are more efficient. Small ion thrusters are 1 by 2 by 1 blocks in size, and large ion thrusters are 2 by 3 by 4 blocks. It takes 6 small ion thrusters to fill the space of a single large ion thruster. These thrusters are electrically powered. They are more efficient in a vacuum, less efficient in an atmosphere. In a vacuum, small ion thrusters are capable of 345.6 kilonewtons of thrust at a cost of 3.36 megawatts for an efficiency of 9.72 watts per newton. In atmosphere, they are only capable of 91.7 kilonewtons of thrust for a cost of 3.36 megawatts with an efficiency of 36.64 watts per newton. They weigh 4,380 kilograms. In a vacuum, large ion thrusters are capable of 4.3 meganewtons of thrust for a cost of 33.6 megawatts at an efficiency of 2.95 watts per newton. In atmosphere, they are capable of 1.1 meganewtons of thrust for 4.3 megawatts of power at an efficiency of 30.55 watts per newton. They weigh 43,200 kilograms. Large ion thrusters are more efficient. Glad you enjoyed the video. How about dropping a like to let me know that you did? Also, if you haven't already, think about subscribing and hitting that bell notification to be notified whenever a new video goes live. Like to see the small ship mega guide? Click the video on the top. If you'd like to see the series in which this ship was designed, click the video on the bottom.